Hello, Mr. Price here, and this is the third video of the January 2006 M2 exam paper. This one is on question 3. Let's have a look. And this one is all about work done, power, kinetic energy, so energies and bits and pieces. Okay, we have a box of mass 50 kilograms and it's dragged along a horizontal floor with a constant force of 400 newtons. And this is acting at an angle from the horizontal. And we want and we know the total resistance to the motion of the box is a magnitude of 300 newtons, and this is remaining constant for now. We know the box starts from rest and passes a point P 25 meters from O with a speed of 2 meters per second. Okay, and for part I, we're being asked to find the increase in kinetic energy of the box. Okay, now you can probably do this quite quickly, but I'm going to model the whole question here. So, in our starting position, here's our box, and it's always a good idea to do this even for 1 mark questions because we're probably going to need to be doing more advanced stuff later on in the question anyway. So we have a 50 kilogram box, okay, and then there's a force of 400 newtons acting at an angle of theta. Were we told the angle? We don't know the angle yet. Okay, and then there's a resistance the other way of 300 newtons. Okay, and this is starting at a speed of 0. And then afterwards we have the same box, same force from an angle with the same resistance, with the same weight, and now it has a speed of 2 meters per second. Okay, so for part I, we're being asked for the increase in kinetic energy. So the change in kinetic energy will be equal to half of the mass, 50, times by the velocity squared. Subtract our initial conditions. This is going to be 0, but I'll do it in full anyway. So a half of 50, 0 squared. Okay, so you should find that that ends up to be 100 joules. And that's part I. For part IB, so that's IA. For IB, we want the work done against the resistance to motion of the box. So we know that a work done is a force multiplied by a distance, and we want the work done of the resistance. Okay, the question is asking us for the work done of the resistance to the motion of the box. So I can say work done resistance is force resistance times by the distance it travels. So the force is 300 newtons, that's staying constant. And it travels a distance of 25 meters was the distance. So 300 lots of 25. So the work done of the resistance was 7,500 joules. Or 7.5 kilojoules. And that's all we need for part B. Okay, the final bit is asking us for, so for question 2, we want this angle here. Okay, so we know the total work done of the whole system is the change in kinetic energy. Okay, so this is the work done of the whole system. So this work done of the whole system is made up of the work done of the driving force, I'm going to call that F, minus the work done of the resistance, which we called R, is equal to the change in kinetic energy. Okay, now we know 2 of these values already, we've just been asked to calculate them. Observe how the question leads you in to what you need to do. So work done of the force minus our work done resistance, which was 7,500, is equal to 100. And we know the work done of the force is going to be the force multiplied by the distance. So Fs equals 7,600 joules. And the distance was 25, so dividing by 25 on both sides, we should get that force to be 304, I believe. 304 newtons. Okay. So this is the overall resultant force acting on our diagram. Okay, so now, if we look back at our diagram, this force here needs to actually be 304 newtons, but it's 400. So obviously this angle here will tell us what we need to get to 400. So 400 cosine of our angle will equal 304. So using inverse cos, you should find that the angle to be somewhere around the region of 40 degrees. 40.536 I make it. And that's job done for question 3.